moving into statistics, you guys are going to learn how to analyze univariate data. That is essentially data that is one variable. So like if you take a survey of the number of siblings that someone has, that would be univariate data because you're just asking for essentially one possible result, however many siblings you have, 2, 3, 12, whatever. That's an example of univariate data, okay? So like I said, number of siblings, heights of everybody in the class. That's what univariate means. So remember, we're taking smart notes, smart notes. Now with data, there's two different types. You have qualitative and you have quantitative. Qualitative data is data that's like categories, such as I am going to do a survey of everyone's favorite candy, or I'm going to take a survey of everyone's favorite holiday or everyone's favorite subject. That's an example of qualitative data because essentially the responses are categories: math, English, science, or Twix, Skittles, Snickers, right? You really aren't provided with a numerical value for your data. But quantitative data is data that can be counted or measured. So like I said earlier, the number of siblings you have, that's an example of quantitative data because your response back is going to be a number. There's two different types of quantitative data. There's discrete and continuous. Discrete data is the number, is something that can be counted, such as the number of CDs you may have, which CDs are extinct, but like you can actually physically go and you can count the number of CDs that somebody has. Another example of discrete would be your number of siblings that you have. You can actually physically count somebody's siblings. The number of red cars in the parking lot, that's something that you can actually physically go out and count. The amount of fish in the sea. Even though the sea is huge, there could be a lot of fish, you could physically sit there and count them all. That's discrete data. Continuous data are things that can be measured, such as how long it takes you to finish a race, how tall you are, the actual length of the fish that's in the sea, the speed a car can go. Okay, these are all examples of quantitative data that can be measured. Okay, see the difference? So when you're doing a statistical investigation, the whole group that you are collecting your data from is known as a population. Okay, so like the 1,557 students that are here at Lake Wells High School, that is our population. Okay. If I wanted to do anything statistical, of course, I want to pull from the entire population. Sometimes when we can't pull from the entire population, then we get a sample. A sample is a small group chosen from the population, okay, such as the IB students at Lake Wells High School. That is a sample of the entire student body population. Now you can have a random sample or a biased sample. A random sample is one where each element has the same chance of being included. A biased sample is one that's not random. So for example, when I said the IB students as a sample, that would be biased because technically everybody is classified under that IB umbrella. But if we're at morning meeting, and let's say the entire student body is at morning meeting, because some people like to skip. But let's say everybody's at morning meeting, and Ms. Dunstan's like, okay, I want you over here, and you over there, and you over there to come down. That's an example of a random sample, because everybody that's in that gym has the same chance of being included. Okay. Now, when there's a large amount of data, okay, and by large, I'm not talking like 20 pieces or 50 pieces. I'm talking more like 200, 300, 500 pieces of data. Sometimes it's easier to interpret the different information about that data if the data is organized into a frequency table, which you'll see soon, or displayed as a graph. And there's a few different ways that you can display data statistically. Now, when you decide to take a sample from a population, there's actually different types of techniques that are used to collect a sample. And it's always important that if you're ever writing any type of scholarly paper, like an internal assessment, and you decide to do something that's statistics-based, you always want to explain the sampling technique you used and why you used it. Because sometimes, depending on the circumstances, one is more readily available than the other. The first, it's the most basic, is your simple random sampling technique. That legit means each member has the same chance of being selected, okay? That's why it's called a random sample. Everyone has an equal chance of being chosen. There's also systematic sampling. It's defined as you collecting data at random intervals. So let's say I wanted to collect data and we had a morning meeting, like, and everybody was back at school. And I stood at the door and I decided to ask every 10th person that walked through the door what their grade level was. That's an example of systematic sampling, because I'm collecting it at regular intervals of every 10th person, or every 5th person, or every 2nd and 6th person. Convenient sampling. That is sampling that's easier to select, and also collecting from people who are likely to respond, right? The easy example I can give of this was A&I. They're in statistics as well. They're actually doing a whole unit-long project. They had to collect data. Once they went around and they still needed about 10 more pieces of data, they used each other in the classroom. That's the people they chose in the classroom. That's an example of convenient sampling, because one, they're nearby, readily available. And on top of that, they're more likely to respond and give you their information because they too have to go through the same project. So they're more likely to respond and help you out. Maybe not like random Joe Schmo in the plaza who you're like, hey, can I have your height and shoe size? And they're like, wow. It's like, okay, thanks for making this that much harder. The last two are kind of combined together because they have the same definition. Just one is random and one is biased. Stratified or quota sampling. This is when you divide a large group into subgroups and each group is represented fairly. So prime example, Ms. Dunstan says she wants to create a committee and every grade level is represented, right? When it says divided into subgroups, that means there's a certain number of freshmen, certain number of sophomores, certain numbers of juniors, certain number of seniors that are chosen that represent how much their group makes up out of the entire population. So let's say, and this is not accurate, but let's say there's 1,000 students at Lake Wells High School. You have 500 freshmen. You have 300 sophomores. You have, that was really, let's say 400. Even though that's not true. It's clearly more than that, but let's just say that here. That's how many of each class that you have. Well, stratified or quota sampling basically takes their respective percentage and they choose that many students from the group to make a committee of 10 students, right? And so that would essentially be 4 freshmen, 3 sophomores, 2 juniors, and 1 senior. And that would represent how much that particular group makes up of the entire population. Now, stratified is random. So like you put all the seniors in one room, you are my 1 senior that's going to be a part of this committee. You put all the juniors in one room, You two are going to be the two juniors. Randomly, everyone has an equal chance of being chosen. The quota, which means biased, she picks one IB student, two IB students, three IB students, four IB students from each class. Or better yet, she picks one athlete, two athletes, three athletes, four athletes. They're from a certain group that only certain people are a part of. That means they're biased, okay? It's a biased sample, it's a quota sampling. Does everybody understand the different type of techniques?
Yes.
So now let's take a look at some of these terms in practice. It says the student counted how many cars passed his house in a 1-minute intervals for 30 minutes, and here are the results. You have to display this data in a frequency table and draw a bar chart for this data, okay? So what a frequency table is, it's legit a table that has 2 columns to it, and each column will have a title. The left side of the table is going to represent what the actual variable is in this particular situation. So it's going to be a number of cars, or I might just say cars. And then the right side is going to say the frequency. So in other words, how many times this particular number occurs in the data set. That's what frequency means, okay? So you literally create a table based off of that. And it's a way to essentially condense all this data into something that's nice and neat, okay? So the smallest number of cars that show up is 20, okay? And as we can see, I have 2 20s there. So 20 shows up twice. 21 is my next one. That shows up 1, 2, 3, 4, 5 times. Okay, and you continue the process to make this frequency table. 22 is next. There's 1, 2, 3, 4, 5, 6, 7. 7 times 22 shows up. So 22 cars pass by for 7 minutes out of this 30-minute interval. And you keep going. All right, I'm going to do the rest off camera, but we'll still do it together as a class. So here's my frequency table. It represents all of my cars and as the number of times they show up. And to be honest, a frequency table is a nicer, neater way of displaying all of this data. Now, if you ever had to create a frequency table yourself, you know that you're correct if your total frequency is exactly essentially the total number, in this case, the total number of minutes that you collected data for. So 2 plus 5 is 7, 7 plus 7 is 14, 14 plus 6 is 20, 20 plus 1 is 21. Add 22, you get 23, 26, 29, 30. So those two numbers should match. The total number of frequencies should match however many data pieces you have. And again, that's a cleaner way of representing all that data. Then you're asked to display this information in a bar chart. A bar chart is what you guys did a long time ago when you were in like elementary school, okay? You always want to make sure that whenever you create your own bar graph or any graph, you label your axes. My x-axis is going to represent the number of cars. And my y-axis is going to represent my frequency. Again, how many times these numbers show up. On my bar graph, your x and y-axis always intersect at what point? Think about coordinate plane. X and y intersect at this point. What's it called?
Origin.
The origin, AKA 0. My first x value is not until 20. So sometimes what you may see is a break in the graph that essentially represents all of the numbers from 0 to 20. Otherwise, you would have to put 20 little lines or 19 little lines from 0 to 20 and then start your graph, okay? So it's like, it's just a little That's all it is. And it represents all the numbers from 0 until the first hash you make. Always make sure you stay consistent with your scale. Over here, I'm going to go by ones as well. 1, 2, 3, 4, 5, 6, 7. 7 is my largest. And then we just make our bars. 20 has 2. 21 has 5. 22 has 7. And so on and so forth. So this is your data. This is a bar graph. Bar charts, bar graphs, the bars do not touch each other, okay? If the bars touch each other, then that has a completely different name, but bar charts, there's space in between the bars. Frequency table, all of your frequencies should add up to be your total pieces of data. And again, it's a condensed way of representing all of your information. Now, there's a lot of values spread out over a wider range of values. It may be more useful to group the data. I was able to do that singular frequency table because I only went from 20 to 28. That was easy to do. But if the data spreads from like 0 all the way up to 200, doing individual, that's too big of a chart. So you create what's known as a frequency distribution. So not a frequency table, but a frequency distribution, because your data is spread out over a wide range. It's distributed over a wider range of values. These 3 bullet points help you in creating those frequency distributions. Usually you get between 5 and 15 groups, also known as classes of equal width. The classes or the groups cover the entire range of values from your data, and the groups or the classes do not overlap each other. When you have a frequency distribution, you draw a histogram over a bar chart. How about that? So here we go. This one is very extensive, okay? It's the ages of 200 members of a tennis club. The ages are in order, but as you can see, they range from 20 all the way up to 69. You're not going to make a regular frequency table with 20, 21, 22, 23, every single individual one till you get to 69. That's ridiculous. That's massive. So you create a frequency distribution, also known as a grouped frequency table. Okay, it's essentially you take the data, you divide it up so that each group is of equal width, like they have the same size, and then you put the data inside of that table. So this is how you do it. You take the largest value, the smallest value, and you subtract. Okay, what number is that? What's 69 minus 20?
49.
49. Then you divide it by the number of groups you want to create. Now, this is if you are creating your own frequency distribution. Let's say I want to create 5 classes, 5 groups. I divide that difference by the number of groups. 49 divided by 5 is what? Wow, you can use your calculator. Go ahead and pull your calculator out. What's 49 divided by 5? Okay, so 9.8, okay? You always round that up to the next whole number, which would be 10. This number right here represents our class width or our group width. That's how large our table is going to be, okay? So I'm gonna create my table over here. It's still gonna have 2 columns. The title of the first column is still gonna be what I'm representing, so it's ages. And then frequency is still my second column. So that hasn't changed. First column represents what it is that we're talking about. The second column is the frequency still. I made 5 classes. Again, I chose 5 because your classes should be in between 5 and 15. There was a great question asked off camera, which said, well, why 5 to 15? Because anything smaller than 5, you're going to have potentially have a lot of data in one of your classes. So you want to try to have a nice number of classes, because then too many classes, there's a possibility that you have a 0 for frequency and you don't want that. So 5 is usually good, maybe 6, 7. It just kind of depends on how much data you have. We have 200 members, 200 ages. So to create the actual range that's going to have a class width of 10, I start with my lowest value and I add that class width to that starting value. So 20 plus 10 is 30, 30 plus 10 is 40, 40 plus 10 is 50, 50 plus 10 is 60. These are known as the lower boundaries, sorry, the lower limits of each class. These are known as lower limits. To get the upper limits, you add the class width. So again, 20 plus 10 is 30, 30 plus 10 is 40, and I continue to add from there.
And I'm confused.
About what?
This adding 10.
Remember, we're adding 10 because that is the width of each class. We got that width by taking the range essentially of our data values, our largest value from our smallest value, and dividing it by the number of classes we wanted. This is how we're going to create our frequency distribution to essentially condense all 200 ages down into a nice distributed table.
But okay, for the orange part, why do we have a 10 interval?
Because that is the width of the class.
And why do we add 10 again?
Because that's the width of the class. So like each one, so this would be considered the first class, the second class, the third class, and so on and so forth. So the class width is represented between the upper limits, the lower limits, and the actual numbers that go between the upper and lower limit of each class. That's what makes it the width. That's how many values are going to be spanning between each class.
So it means between 20 and 30?
Well, we like, there's a reason why I put a space in because I haven't finished up that part yet, but we're essentially going to represent all the ages for the first class from 20 all the way up to 30. So we represent that using a compound inequality like so. So in the first class, I'm going to include all the ages from 20, including 20, all the way up to 30, but not including 30 for the first class. 30 is going to be included with the second class because it's going to be less than or equal to here. The 40 is not included in the second class. It's included in the third class. So that by writing the compound inequality like so, you are taking into account that there are no gaps in any of the ages. Luckily enough, age is only measured by a whole number. But if this was like shoe size or something, you're not leaving out any 0.5s or any 0.2s or anything like that. And then from there, you put however many actually lie in each of the classes. Now I'll definitely do this because you guys don't have a hard copy of this. And I'm also going to do this off camera. I essentially count how many ages lie in between 20 and 30, not including 30. How many lie in between 30 and 40, not including 40, and so on and so forth. So this will be your frequency distribution. I went through and I literally counted all of my data and I put it into this distribution. And it's that right here, this table is a more condensed way instead of actually writing out all 200 pieces of data. Okay. And again, I know that I didn't miss any ages because my frequency should total the number of people that are in the tennis club. And now to create my histogram. A histogram is very different from a bar graph. The main difference is that the bars touch. A bar graph, the bars do not touch. A histogram, the bars do touch. So again, I start at 0. My first age isn't until 20, so I'm going to include a break. And I'm going to go from 20, 30, 40. I keep my scale consistent. And then, of course, you always label. So ages is my x-axis, frequency is my y-axis. I'm going to go by tens on my y-axis. The scale does not have to be the same from the x and the y-axis, but it does have to be consistent. So I went by tens on my x-axis, tens on my y-axis. And so then from 20 to 30, I have 16 members. From 30 to 40, I have 38. From 40 to 50, I have 68. Then I have 55. And then I got 23. And this will be my histogram. As you can see, the bars are touching at each of the points. Do realize that this should have been at 60. That's my mistake. Should have been at 50. Should have been at 40. At 30. At 70. One thing that you have to be careful of, and IB gives these types of problems, and sometimes if you ever created your own, you may do this as well, is that you may say, oh, well, the ages of people don't include, like there are no such things as half ages. So we could have gone from 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69. And I could have put less than or equal to for these. The width is still 10 for the upper limits, the lower limits, and in between. Because if I'm including 29, 20 to 29, that's 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. That's still a width of 10. There's just one difference that you're going to have to deal with. Frequency is still the same. So that's still 16, 38, 23. Frequencies are still the same. The biggest difference when your classes do not overlap, like they're not the same value, like these aren't, you have to find what's known as upper boundaries and lower boundaries. What these boundaries are is where the actual bars of your histogram are going to touch. Okay? Because if I were to graph it the way that it is, I would have a gap between 29 and 30. I'll have a gap between 39 and 40, and so on and so forth. But a histogram, the bars are supposed to touch. So how do you get them to touch? By finding the upper and lower boundaries. This is found by taking the average between each class. This is how you find the upper and lower boundaries, by taking the average between each class. So you take the upper limit of one class, the lower limit of the next class, and you find the average. So that's 29 plus 30 divided by 2, which is what? $29.5. The halfway point between 29 and 30 is 29.5. And that becomes the upper limit of your first class and the lower limit of your second class. And you repeat, you find the next upper and lower limit. So 39 plus 40 divided by 2 is, come on, y'all.
39.5.
So that becomes the upper limit of your second class and the lower limit of your third class. By doing this, this is what's going to cause your bars to touch. The next one's gonna be 49.5. The next one's gonna be 59.5. And because this is a histogram and the widths have got to be the same, you're not going to end at 69, you're going to end at 69.5. It has to follow the same pattern. So like if there were more ages older than 69, the next class would have been 70 to 79. It still follows the same pattern. Similarly, the lower limit of the first class would be 19.5. Because if I had anybody younger in the club, it would have been 19 or 10 to 19. So it still follows the same pattern. And these orange values is what you would graph instead when your frequency distribution does not touch like these do. So the upper limit and the lower limit are not the same. When you graph this, it still is going to go from 20 to 30 to 40 to 50 and so on and so forth. Okay. It's just that when you actually do your bars, you're going to start at 19.5. So you're going to be just a little bit before 20 and a little bit before 30 to indicate that 0.5. You're going to be a little bit before 30 and then a little bit before 40 for that 39.5. And the thing is that like a lot of times with this unit, you'll be provided graph paper. So you'll be able to hit a 39.5 or in between 39 and 40. But this is how you can compensate to make sure that your bars are going to touch each other. So it should fall just a little bit before 50 for the next class, a little bit before 60 for the class after that, and a little bit before 70 for that final class. So there should be there should be a distinction. Should be off-centered. All right, so to round up today, we're going to talk about some things that should be familiar. Okay, if you've taken the SAT or ACT by this point, you should definitely know some of these words, such as mean, median, and mode. They're called central tendencies because they basically tell you about the middle of the data. Mean, median, and mode tells you about the middle of the data. What does mode mean?
No idea.
What does mode mean? Think back to elementary school. It's when you first learned about mean, median, and mode. The mode is the number that occurs most often. So mode sounds like most, the number that occurs most often. Okay. That's definitely in your SAT, ACT books and study guides. Mode is the number that appears the most often. So what would be the mode in this example?
15.
It would be 15 because it's the one that appears the most out of all the other numbers. Okay? That's what mode means.
What does mean and median?
Okay, well, we're gonna go through each one. Let's look at some more examples of each. So when you're presented with a frequency table, the mode is the group with the biggest frequency. Because unlike that example that was in pink on the other slide, you don't have all the data listed out for you to look at it. So you have to look and see, okay, what's the largest frequency here? In example A,
7.
it's 7. So the mode for this example is not 7, it's 1 goal. Because remember, this is univariate data. So here we were told the number of goals that were made and how often they were made. So you look here to see which one is the largest, but your answer is actually essentially the X value. Now you'll see this word. It's called modal class. Modal means mode. It's just that when you have a class, it's going to be a range of values, not just one singular number. Again, you still look at the largest frequency, which is,
7.
so you're looking for the class that's associated with it. So the modal class is the class with the largest frequency, and that's 15 to 20. You write it exactly how they wrote it. And that's how you find the mode. Now the mean is what again? What's another word for mean? It's the average. This is old school. Okay, like before we started putting weight to your grades or whatever, this is how we used to figure out your grade. We just add up all the values and divide by however many assignments we had. That's how you find the mean, the average. The formula for that is this. You had the sigma notation. We've seen that. What does sigma mean? The E, what does that mean? It was used with sequences, but it represented the sum of all of your data values, and N is the number of data values in your population. So you add up all of your X values and divide by however many are in your population. So here, to find the mean, we would add all these values up and then divide by the number that we have, which is 1, 2, 3, 4, 5, 6, which is 7. That's how we find the mean. Add up all the values that were given and then divide by however many we have. Find my mean for both of these examples, please. What do we get?
For the first one, I got 85. For the second one, I got 14.6. Wait, 4.6, my bad.
4.6?
Yeah.
Did it end at 6?
Oh, I'm so sorry. 4.16 infinitely 6.
Okay, so it's 4.666 repeating. Then it's what to 3 significant figures?
For the 17.
Don't forget 3 significant figures. Okay, that's how you find mean. Of course, this is what you did in Algebra 1 when you first went over statistics. Okay, and IB is you may get all your data listed out, but you may more than likely get it into a frequency table, like so. So how do you do it this way? Well, first off, you have a frequency table and then you have a frequency distribution. Okay, in a frequency table, remember, all this was condensing all of your data down into something nice and simple. This here means there's 11 zeros, 10 ones, 19 twos, and 10 threes. Instead of sitting there and doing 0 plus 0 plus 0 plus 0 11 times, plus 1 plus 1 plus 1 plus 1 10 times, and 2 plus 2 plus 2 plus 2 19 times, and 3 plus 3 plus 10 times, you can multiply the X value by the frequency and then divide by the total frequency. Okay? Because when you multiply each of your X values by the frequency and add them up, you're technically finding the total sum of adding all of those up. And then you divide by your total frequency, because remember, this total will represent how many grades you actually have. What's 11 plus 10 plus 19 plus 10? So figure this out. Do the multiplication, do the sum, divide by 50. So 1.56 would be the mean. That means the average grade was 1.56. Now, whether it's talking about ages or grades or people or anything like that, mean is always, if it comes out as a decimal, you write it as a decimal. Even if we're talking about things that shouldn't be decimal, like people, that's still the mean. That's the average, okay? So for a frequency table, you take your X values, you multiply them by the frequency, and you add them up. That's your numerator. Then your total frequency is your denominator. For a grouped frequency table, it's different. Because one here, do I know what my raw data was? No. So because of this, we can never find an exact mean, but we can find an estimate. And you'll see that wording. It'll say estimate the mean, and they'll give you a group frequency table. Because there's no way I'm going to know exactly the 4 ages that are between 10 and 12. I might have 4 10s, or I can have 2 10s and 2 11s, or I can have 1 10 and 3. You see what I'm saying? I don't know. So I can estimate the mean. And to do that, instead of taking the X values, because I have a range, you take the sum of the midpoints of each class, and you multiply that by the frequency. And that is your numerator. Then of course you divide by your total frequency, and the total frequency is your denominator. So you take the midpoint of each class. What's the midpoint between 10 and 12?
11,
12 and 14,
13.
15, and then 17. I take each of those midpoints, multiply them by the frequency, add them up, and then divide by the total frequency. What's 4 plus 8 plus 5 plus 3?
20.
And that will give me an estimate for my mean, which is the only thing I can do when I have a grouped frequency table or frequency distribution.
13.7.
So then the average age would be 13.7. Again, age is something that's usually represented with a whole number, but whatever we do mean, you provide the decimals. And that's how you do it with an IB problem. Okay? So if you notice, when we've done mean and mode, I've showed you the old school way that you used to do it, right? And then I showed you how it's done in IB. Old school way, IB. This next problem, to be honest, is more so the SAT practice problem, because again, mean, median, mode is something that's covered in SAT. And so I don't get an opportunity to review SAT stuff with you guys. So hey, why not? Especially when we're doing a top part of it. It's Atlanta's mathematics test grades are 86, 93, 89, and 85. What score must she get on the 5th test in order to get a mean of 90 for the term? How would you figure this out?
Can't you just plug it into a formula or something?
What formula?
No idea.
Okay. First off, what does mean mean?
Average.
It's the average. How do you find the average?
Add them all up and divide by the frequency.
Okay, so I added my scores, right? 86, 93, 89, and 85. She's trying to figure out what she must get on the 5th test in order to get a mean of 90. So I have 4 tests here. I don't know the 5th test. But if I add that 5th test, whatever it is, and divide by how many? 5, I should get an average of 90. So this is exactly how you would set the problem up to find what X would have to be. Go ahead and solve this one out. So multiply both sides by 5, you get 450. You would add up this entire total. What's 86 plus 93 plus 89 plus 85? So then you subtract 353 from both sides. You borrow. And so X is equal to 97. So that's what she would have to get on her 5th test to get an average of a 90. And this is a very typical ACT problem. Maybe something around the easier level, maybe even the medium level, but it's common. Last thing we need to go over is median. Think about it. Median means what? The middle. That thing that, is in the middle of the road when you're driving, like you're driving down 60, there's that grassy area in the middle. It's called the median. It's because it's in the middle. Okay? Don't want to run over the median. So it's going to be the value that's in the middle, but when things are in order, when all of your data is in order. So if it's not in order, like this data is, you want to put it in order. Okay? So that's going to be 2, 5, 7, 12, 13, 14, 19. 423s, 29, 39, 42, and a 55. Put all your data in order. And then old school, this is what y'all used to do. You used to go from each, take one away from each end. Take away the largest value and the smallest value, and you would continue to cancel out numbers until you reached the value in the middle. So my median would be 23.
What is this to middle?
I was just about to say that. So let's say I had this data again, but this time, I'm not going to do all the data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just say this is all the data I have, right? I could still do the same thing. Cancel out one from each side. But when I have two numbers that are in the middle, this happens when there's an even number of pieces of data. When it's odd, it's easy. I had 15 pieces for the problem that we did. Here, the one I just made up, it was an even number. You take the average. You find that value in the middle. So then, again, to find average, you just take the two numbers, add them up, divide by 2.
13.5.
So it'll be 13.5, and that'll be the median. Okay. NIV median is actually done a little bit differently because a lot of times you're asked to find the median with different types of displays of data versus a frequency table or frequency distribution. So we'll visit that on Wednesday. So this is the first little bit of statistics. Lots of definitions, lots of terminology. Median, the value in the middle. Mean, average. You add them up, divide by the however many you have, or you find the midpoints and multiply them by the frequencies, add them up and divide by your total frequency. Mode or modal class, the number that appears the most. You have a histogram, bars touch, bar graph, bars don't touch, frequency tables, and frequency distributions. You have your different sampling techniques, what a sample is, random or biased, qualitative versus quantitative data. All that is just the very basics of statistics.